Good evening, everyone, and welcome to LSU Science Cafe. I'm Steve Beck with the LSU Office of Research and Economic Development, and we're excited to bring you tonight's program featuring Dr. Mary Beth Lima, who has participated in more than 50 collaborations over the past 23 years through the LSU Community Playground Project, which is an example of community-based transformational engineering and design. Tonight, she is joined by her colleagues across the country who are promoting social justice and peace through engineering. Live closed captioning for this event is available. Click on the live transcript button at the bottom of your screen. Despite our physical distance, our goal is to continue to build a strong, informed community by providing access to reliable information, new ideas, and cutting-edge research, scholarship, and creativity from faculty, experts, and researchers in fields across the university. Tonight's event is brought to you in partnership with local public radio station WRKF 89.3 FM, your source for programs like Science Friday, the TED Radio Hour, and Hidden Brain. You can see the program schedule at wrkf.org. WRKF will be giving away one stainless steel NPR Science Friday beverage tumbler to one lucky audience member tonight. To enter the drawing, click on the link in the chat box and fill out the Google form with your contact information. Also, please be aware that this online event is being recorded and it will be available with the transcription from the LSU Research website within the next few days. And now, without further ado, I'd like to introduce tonight's speakers. Dr. Mary Beth Lima is the Cliff and Nancy Spanier Alumni Professor and Chair of the LSU Department of Biological and Agricultural Engineering. She authored the book, Building Playgrounds, Engaging Communities, which chronicles the community-based engineering work she does to co-design and build playgrounds with children at the center of the design process. Dr. Ann Christie is a professor of engineering education and food, agricultural, and biological engineering, as well as the assistant dean for teaching and learning in the College of Engineering at The Ohio State University. Previously, she worked in the engineering consulting industry. She is a registered professional engineer and a second-generation woman engineer. Her mother worked as an industrial engineer in the aeronautical industry. Dr. Christie's research is in bioenergy, environment, and engineering education, and it has generated more than 130 publications, including over 40 on topics in teaching and learning. Dr. Malini Natarajarathinam is an associate professor of engineering technology and industrial distribution and co-director of the Texas A&M Institute of Technology-Infused Learning. Before coming to academia, she worked with several automotive companies on transportation, material handling, and decision analysis systems. And Dr. Julia Thompson is an assistant professor and director of the Innovation Hive and Engineering Partnerships at the University of San Francisco. Dr. Thompson has a passion for integrating the soul's work into the engineering design process and technology. She is driven to help students and people in general look at technology as a pathway toward the healing of Earth and unjust social structures. After the presentations, we'll have a moderated question and answer session. To participate, please use the Q&A button to enter your questions. We will be monitoring that section and relaying them to our panelists. And now it's my pleasure to turn it over to our guest speakers. Mary Beth?
Thank you, Steve. I want you to imagine that you are a 4-year-old and that you are playing on your first community school playground. If you take a look at this picture, what you see is a yellow bucket ball. That is a funnel-shaped sort of basketball goal that you throw a utility ball into and it comes out in any of 3 directions. To the left of that is a geodesic dome climber. And to the left of that, where the people are on the left side of the photo, there's a rusty red gate that really goes to nowhere. And there's a blown up picture of that in the lower left part of your screen. And as a 4-year-old, you and 60 of your friends are playing on this playground. And if you look at the border to the playground, there is a chain link fence running through the center with barbed wire on top. And there's a single family dwelling on the other side of that fence. And what you see is a playground for 2 kids that has a tree house and a slide and a swing and a cool climber. And so this essentially is why I do humanitarian engineering. It is to address inequity in built form. My students and I were collaborating with this community to bring a new playground to these 60 pre-K kids. And we were several months into the design process and had, again, just taken to calling that little gate the gate to nowhere, because that's what it was. And I asked the principal the story about that gate, and she said, well, there used to be some play equipment here that was removed for safety purposes because it was old, but whoever removed the equipment didn't remove the gate. But it's the kids' favorite piece of equipment on the playground. And I was surprised by that and asked why. And she said, well, it's because the teachers line up those kids every day at recess in front of that gate. And they ask them, where do you want to go today? Anywhere in the universe. And when the child in line has thought of the place that they want to go, they run through the gate and scream where they're going as they run through the gate. And for me, that was an amazing moment, because my students and I, in our community engaged design endeavors, always think about not making bad assumptions. And actually, we had made a terrible assumption. What we were calling a gate to nowhere was really a portal to anywhere. And it also made me stand in awe of the teacher of a bunch of pre-K kids who would say, gosh, if I'm faced with this situation, what can I do to encourage my students to dream despite this amazing playground right on the other side of the gate? And I've tried to take that lesson with me in my work as I move forward, which is that with just a little bit of love and ingenuity, sometimes you can turn a gate to nowhere into a portal to anywhere. Next slide. So in terms of humanitarian engineering, this is just the application of engineering principles to improving the well-being of people and communities that are disadvantaged. And so in that capacity, we create designs which are just detailed plans that are community driven. In other words, they're driven by the community themselves. They involve lots of people with different interests and different expertise areas. They're affordable and sustainable because they have to last a long time, and they're inclusive. Not just because they comply with the Americans with Disabilities Act, but because we want them to be as welcoming as possible. And so toward that, we try to look towards something called the soul of the community, where we spend time engaged with the community and say, what is it that's special and unique about this community? And how are we going to translate those special, unique things into design elements in a playground? Next slide. So what engineers do is we follow a 7-step roadmap of sorts called the engineering design method. And the only thing that distinguishes one type of engineer from another is the type of artifact that you apply this roadmap to. And so I'm just going to run through the 7 steps of the engineering method as they apply to our community-based playgrounds. So step 1 is identifying a problem to be solved or a situation in which you're trying to affect a positive change. And for us, these come from the community. So we might have a call from a community saying, hey, we've got a play desert, we want a new playground, or a school might be in need of an upgrade. And so once we've established what that situation is, we move into specifications development and planning. And so what we're doing is collecting a lot of data, especially from the true experts at play, and that's kids, because they're the ones that are out there playing in their community every day and on the playgrounds, and they're also the experts at their communities. So we ask them to draw their dream playgrounds, even if it's 3 or 4. We ask them to draw how they play, because we can get insight into that as well. And while we are collecting all of that data from kids, we're also working with some of the safety standards that are established by groups like ASTM, the American Society for Testing and Materials, or the Consumer Product Safety Commission that publishes the Public Playground Safety Handbook. So we want to make sure that equipment's not too high, that there aren't any openings in which kids can get stuck and things like that. So once we finish these 2 steps, we then move on to the 3rd and 4th step, which is conceptual design and detailed design. So in conceptual design, you're trying to brainstorm as many different possibilities as you can into what your community-based playground is going to look like. And typically what I'll do is split up students into small groups, and each one will come up with their own design concept so that we can generate 8, 9, or 10 different design concepts for a single playground. And then we go through a process with the community of consolidating all of those into a detailed design where the kids pick which parts of each design that they like the most. And again, we do a frequency analysis to try to figure out what are those recurring elements that we have to include, and what are the really neat spark elements that just, again, help to establish that soul of the community. And once we have that, we move into a detailed design. We write a bid specification, which is going to tell a company exactly how many components of everything that we need that we're going to purchase and then deliver to our site. So in our 5th step, we're actually coming out as volunteers to help to build the playground that we co-designed with our community. And that's important for several reasons. It's really good for the students, my students, because they've gone through the whole process of having an idea and then translating it into a design on paper, and then actually getting to build it in actual real time. It's really useful for affordability. It saves a lot of money, but it also builds a lot of community spirit. And so we think that's really important. Once the playground is deployed, we want it to last as long as possible. So we develop a really good service and maintenance plan to make sure that we're doing things like keeping up that surfacing, that cushy stuff that cushions falls. We're making sure it's replenished. We're tightening hardware once a year so that we can extend the useful life of this playground as long as possible. And in the last step, eventually your design is going to wear out. So either you're going to redesign it or upgrade it, or you may have to retire and dispose of it. And so in closing, humanitarian engineering is, I have come to believe, it's not just a matter of listening with your ears, you also have to listen with your heart when you're working with community. And going back to that playground that I started off this presentation with, we were able to get a big grant and build a really nice playground that more than rivaled the playground across the chain link fence with the barbed wire. But we really left the portal to anywhere as part of that playground because we felt like that was emblematic of the soul of the community. And with that, I'm going to baton pass to Ann Christie, who's going to talk about her humanitarian engineering endeavors.
Well, thank you very much, Mary Beth. And so I'd like to share a couple projects that my students have worked on at Ohio State University. And the first one is, next slide, please, is working with the local food bank. So the Mid-Ohio Food Bank, in addition to having food pantries throughout the city where people can come who don't have access to food. But these food pantries can only handle shelf-stable foods. And so they do not handle produce. They do not have the way to maintain it. And yet the food bank gets tons and tons of produce donated from local farmers, from local grocery stores, from produce that's about at the end of its sell-by date kind of thing. And so how to get this food into the hands of people who, particularly those who live in what we call food deserts in the city. So they've developed this called PopUp mobile produce markets, and they'll take one of these refrigerated trucks like is shown in the slide here, fill it with pallets of whatever produce came in that day. So you never quite know what you're going to get when this truck shows up. And then gathering groups of volunteers to set up one of these in a parking lot. You get the agreement of the parking lot owner, etc. But we'll put up tables, we'll put up tents, we'll help unload the trucks, and then we'll assist people to go through the line and have the dignity of choosing the food they want to take home to their family. Next slide, please. So that's the context of this project. But by working on these kind of pop-up produce markets, I have noticed that it gets mighty hot. Maybe not as hot as in Baton Rouge, but it's pretty hot, even here in Columbus, Ohio. And once the truck delivers the food on the pallets, it leaves. So we don't have a refrigerator truck and we don't have electricity or anything else. So you get fresh food sitting on blacktop for a number of hours while you're setting up, distributing, and then whatever teardown. And so the project that my students undertake is to design cooling methods for this food. Sometimes the trucks will arrive and they'll have milk products, milk or yogurt or those sort of things, and we have to turn it down because we cannot keep those kind of materials safe during the 5 hours or so of the produce market. But if we had a way to refrigerate things, to say nothing of some of the produce itself, can be wilted and adversely affected, shall we say, by sitting on blacktop for hours. So this was the project that my students had before them as part of a course that they take in their junior year. Next slide, please. And these are pictures of some of the students there. So they were asked to go through only step 3 of Mary Beth's 7-step engineering design process. So their end product is a conceptual design, or actually several conceptual designs. And then we talk about which ones would be most likely to move forward. Next slide, please. But the other thing that they learn about is that engineering is about meeting needs. And it's also about not jumping to the first solution, the first answer that they think is the right one. And so just like Mary Beth and her students listened for the soul of their community, what my students are learning is that they also need to consider many different factors and the needs of the different stakeholders, whether it's the people standing in line for hours, sometimes standing in line overnight so that they didn't miss their space in the line, but also the needs of the volunteers, the needs of the food bank, the needs of the property owner and nearby property owners, and understanding that their design needs to meet this varied group of needs and being sensitive to that in the interactions. Next slide, please. So the second project that I'd like to share is one that I've also done, different class, but same agricultural biological engineers. And this is working sort of as a pseudo environmental consulting firm, specifically working with an abandoned hazardous waste landfill site that's in northeastern Ohio, looking at options for remediation, looking at how they could prevent it from continuing to harm people, but also how could it have been avoided in the first place. Next slide, please. Now, they don't actually go on site. My students aren't trained to be hazmat folks in the full moon suits, et cetera, although I've personally done that professionally. But they do study the site by taking readings around the perimeter, by looking at reports and documents and maps and aerial photographs of it, and developing an understanding of the way engineering has to interact across the constraints that the environment poses, political, social, psychological constraints, and the ethical constraints of what is the right thing to do. And that's not always obvious. Next slide, please. So here's some student quotes from this project. And they were particularly struck, my students were, that even as they're learning about some of these things, and some of this is just in time learning, so they didn't walk into the class knowing about how to read a geologic report or how groundwater flows underneath landfills in particular. But they're then realizing that decisions are being made by the local people, by the township trustees, by decision makers that by people who don't fully understand the things that my students are just now learning about, and recognizing that this is a bigger problem. And I think it's also very telling that as they think about this deeply experience, being on these kind of sites or near these kind of sites, talking to people who are impacted by them, that they start to see their responsibility as future engineers for working with their local communities and helping both solve problems, but also prevent problems that are preventable as long as you work together. So next slide, please. So those are just a few of the humanitarian engineering projects that I've had the privilege of working with students on. Thank you.
All right. Howdy. Good evening. My name is Malini Natarajaratnam. I'm a faculty with the Industrial Distribution Program at Texas A&M, and my formal training is in industrial engineering, supply chain management. So I do teach our students in basics in logistics, transportation, inventory, material handling, but I've also had the pleasure and privilege of working with food banks on streamlining their operations in terms of delivery of food, how to distribute them efficiently, how to manage their warehouse space. So taking the same decisions that we would take for a company, but from a nonprofit situation. So when students had always asked me about these projects that I'm working on, and they found it very interesting and they were looking for opportunities to get involved, I launched the Hunger Free Texas project in 2016, where our groups of students, we had hundreds of students every semester working with different pantries in the state of Texas. And our students would be a class project, if they would be doing for a company, it would be similar to that, but they would be doing with these pantries where they look at their operations and assess how these operations can be done better, how can they order better, how can they hold inventory better, how can they distribute their products to their clients better. So they're taking decisions that they would as a technical industrial engineer, what they would do, but for these pantries, with the goal to improve their process efficiency and to then improve the impact of these pantries in their local communities. So we'll go to the next slide and I'll show you a small video of how this project happened. And then I'll talk a little bit more about that. Thank you, Holly. we can maybe move on to the next slide. Maybe that'll stop it. Okay. So that just shows a little bit about our project for the very first time, and we have been doing that ever since. So this video we did more to show how much the focus of this video was more to how much we focused on listening to the community, even way before the project started, for us as faculty, going out to the agencies, talking to them. And one, listening to the agencies, and also telling the agencies about how to work with these students and what to expect, and also to guide them through, hey, these are some of the things our students can do, would like to do, would be useful for them to do. And when we listened, the students loved it. And as you can saw the video, as we went through the project, the food bank saw the impact of this, and they decided to fund all the solutions that our students were providing. So when the presentations, they assessed, and at that moment, like right at spot, they funded these solutions that our students were providing to make real impact in the community. So I'm very glad to be part of that. And going back to how Dr. Lima and Christy were sharing some quotes, this is a quote that I always will remember. While we were at a field trip with my students, and we were touring through one of the pantries, and this student came by me and he said, "Dr. Malini, I never knew there were so many people doing good in the community. And now I feel like, society's got my back." It felt like, he all of a sudden, like engineering was this thing that had no connection to the community, and now he started believing in engineering and how it's impacting him and how he could trust it. And that's something that will always stay with me, to just show the impact of how engineering can be impactful in the community in real time, and it doesn't have to wait a certain time. But we're glad to be part of this, but I'm also glad to have mentors like all of the folks up here. So, and thank you for the invitation. Thank you.
Okay. Hi, my name is Julia Thompson. I am currently at University of San Francisco, but actually I'm going to be talking about some projects I did when I was at San Jose State a couple of years back. And so I ran a senior project class, and there we had student groups working with a whole bunch of different organizations, and it was really great. And I think echoing the kind of the thread about this element of building on relationships and building on community needs that are unique and specific to the space. And so this first picture on the left was the opening of the ceremony for a shower and washer dryer unit for the Gilroy Compassion Center. And so it was placed in a church parking lot, and that parking lot allows people to park their car safely at night. And there's a lot of homelessness due to high rates and a lot of evictions in the Bay Area. And so the church had decided that they wanted to allow people to come and stay safely in this space, but they didn't have a place to shower, and they didn't have a place to do their laundry. And so we were able to communicate with the center and build out a storage unit and get that up and running. Okay, next slide. So once that was built, this was actually for the same organization. They said that the day center needed more storage lockers, that there was a lot of people that came to meet with the caseworkers, but they didn't have a place to save their space, and they also didn't want to oversee the lockers. And so a student group figured out how to install automatic locking systems, so you can punch in a code. And you can kind of see the beauty of this process is also this hands-on, and you get to really kind of create friendships along the ways, and that there is the technology itself, but it's also this relational piece, both with the community and amongst the students. This one actually became an important learning lesson, that one of the issues with the design function was that it automatically went to open if you unplugged it. And so if you, when they installed the lockers, someone tripped on the cord and all the lockers opened. And it really reduced the trust in the locker itself. And no one actually ended up using it because they realized that it could be opened. And so we actually made, updated that system and made a new set of lockers that automatically went to shut with a manual override, so that in case there was a power outage, the people working in the center had a physical way to open up the lockers to get the items out. Okay, next slide. Another one of our partners was the South Bay Clean Creek Coalition. And here we have an underwater drone that identifies fish. The researchers we were working with would really want to be able to see if we could detect Chinook salmon in the river, but I thought it was pretty cool that they were able to be able to detect that there was fish at all. And so we kind of ended up recognizing that if the machine could take a picture, a human could do the fine work of determining what type of fish it was. And on the upper left, we have some students doing a beach cleanup and recognizing the importance of kind of getting your hands dirty and getting familiar with the organizations that you're working with and the space you're working with, that it's not just about the technology. Going back to the relationship building, just like doing the volunteer cleanup days is an important thread in building that relationship connected to the design process. Okay, next slide. Two other projects we have here is educational exhibits, and this is for this tech museum at San Jose. And the one on the left was an aquaponics system that was monitored so that you can see kind of where the different levels of nitrites in the water, and it would also, that informed the people that were working there if anything needed to be added. It also had a benefit of, in that part of the museum, little children weren't as engaged. And so finally there was a place for like 5-year-olds to look at the fish, and like they ended up having names. They had a code in case a fish died, and so that they wouldn't have to, they could sweep it up fast. And so that was one thing our students were able to both build the structure, but also integrate it with the technical levels and sensors associated. And on the right, we had an exhibit of a 3D printed model of a tower, and it was about 3 feet tall, and they had programmable lights on it. And it was connected to San Jose was actually had a light tower in the 1800s that was an inspiration for the Eiffel Tower. And so there had been some history, and the person actually kind of taking the picture on the right was making a documentary of it. And so he really kind of was part of the sponsorship of this this project particular. And so I really love these projects because they have been able to really integrate some of the history and culture and issues that San Jose was facing and is facing today. Okay, last slide. So the last slide I wanted to kind of talk about at the last project is a group of students, and they came to me with the idea, and it was to build an app that connected students who were food insecure with excess food on campus. And so that if you had extra food from an event, you could put that on this app, and then it would ping any students who signed up. And they ended up winning the local innovation competition, and they were incredibly passionate. And so it was really nice to kind of feel like we were a class that was an incubator for people that had passion projects, that they wanted to go through the engineering design cycle to solve problems that they saw were relevant in their community. Okay. And that is all. Thanks so much.
Thank you, everyone. Wow, there are just some absolutely fabulous projects there. I am really just, they blow me away. And it's just really inspiring as to the kind of work that you do. Mary Beth, I really love how you're engaging in building kind of public areas that are common to a community, but are focused on the kids. And I was wondering if you could talk a little bit about the importance of common public spaces, because I know that we've talked about this in before, that the value of having spaces where a community, a group of people can feel safe and engaged, and how does that inspire you and your students to work more deeply in this area? And actually, I would also kind of pass this along to all of our panelists to answer, because I think that all of the work that you do addresses this in some way. But Mary Beth, if you could start off.
Sure, and I'd really like to thank my colleagues. We're actually collaborators on a presentation that we're doing tomorrow at a conference for the American Society for Engineering Education. And I think it's really important in terms of building communities. I know y'all heard the thread was relationship building. We all build relationships as well. There are not, I don't feel like humanitarian is a great big space yet, but I feel like there are a lot of people really working toward it. And I think that relationship building is a key part of that, and listening. Again, that whole listening with your heart and your ears, listening deeply and working together is really a critical piece of what we do, certainly as professionals. And then I think in our, in the projects that we have chosen. And so, yeah, so I think if you sort of think about it more broadly in terms of communities, I feel like we tend to be very separated. We're polarized, and people are not finding places to gather. There's a book called Bowling Alone, which sort of traces the deterioration of gathering spaces in our society. And so, for me, I think designing playgrounds, designing parks is super important, that you are designing. A lot of times the soul of the community piece that we do come up with has something to do with gathering. And so really, your elements to connect to each other are a critical part of what we would come up with as a playground or a park. But I think that finding those spaces is really important. But I also think that making sure that people have access to them is really important. It is shocking to me how few kids have access to play spaces that are safe and fun and modern. And so that's a big piece of why I do what I do as well. And I'll baton pass to my colleagues.
Well, Dr. Christie, if I could address something really specific about your presentation, I was very struck by the approach that you're taking on addressing food insecurity and food deserts. It's a nationwide problem, but here in Louisiana and Baton Rouge in particular, there are many places where there's simply a lack of access to food. And so I'm wondering how you pick or how you identify the public spaces to do this engagement. And we actually have a question about kind of a functional question of, what do you do with the food that's left over at the end, if there is any food left over at the end? So how do you decide on where the pop-up locations happen, and how do you calculate that with respect to having the biggest effect on the community?
Unmute first. It's about relationships, as we've been saying around here. So the Mid-Ohio Food Bank takes a a look and an ongoing look at where are the food deserts in our community. And then we try to find organizations in those places. So it's not somebody swooping in from outside, but find a nucleus. It can be just 2 or 3 people, but if we can then surround those people with some folks who've done it elsewhere, teach them how to do it. It's the old about teaching someone to fish rather than handing them a fish. And so some of the pictures in that slide show, where were those? The first one was in a parking lot behind a grocery store next to an abandoned shopping mall that had gone bankrupt decades before, frankly. That was sponsored by a very small local congregation church. It started small, it got bigger. Some other local churches, we knew this was a food desert, noticed it and sent a few people to volunteer with us. Next thing, we were empowering those congregations to start their own. And it got to the point where we had enough of these pop-up produce markets that we could move to a different part of the city. But it's about being, again, listening and being willing to partner with folks that you might not even know, might not ever meet, except you're coming together to meet a common need. But anyway, so, and please don't think that I'm the one making these decisions. I'm just interjecting my students into a much larger situation and give a lot of credit to the Mid-Ohio Food Bank. Second question, what do we do with food that's left over in any of these pop-up produce markets? Because it can't go back to the food bank. So what first of all, it doesn't happen that often. And when it does, it's sometimes something odd or just something that we got tons of. Like, if we got a load of turnips sometimes, or spaghetti squash. I love spaghetti squash, but sometimes our folks that are coming through the line have never seen it before and they're not quite sure what to do with it. I know one time we just had so much cabbage, we couldn't give enough of it away. What do we do with it? We take it to one of our soup kitchens in the area, folks that are a standing location that provides hot meals, sometimes 1 a day, sometimes 2 a day. We know who is cooking that day, and we'll bring that over, and guess what? They're going to have an addition to their already planned menu, and this has worked fairly well. Yeah, but like I say, we don't tend to have a lot of waste or unused. More often, we'll frankly run out of food. Sometimes before we've run out of people in the line. In that case, then we've had several volunteers take them physically to the local farm, wherever the local food pantry is. We may not be able to get them produce, but we can at least get them hooked up with a food pantry where they can return in the future. So that's been our process thus far.
Dr. Natarajan, I'm sorry, I stumbled on the name. I thought I was going to make it through without doing that. Dr. Malini, how do you, I mean, we've heard from your colleagues that it is about community building. It's about listening to people. It's about connecting with other people. With the project that you had, how did you get your students talking or identifying the people that your students needed to talk to? Where did that connection come in? I found it very inspiring that they were able to invest so much time and effort in addressing these issues. How did you give them the connections or direct them towards those connections?
Thank you, Steve. So my work working with the agencies, like for example, if this project is done in a semester, like in the spring starting January, I start identifying agencies that would be interested in working with the students in the previous year around summer. And then once you start talking, of course, every agency is always open to working with students. All food agencies are looking for younger people to get involved because that's a big need in that community right now. So they do want to get, when you go talk to them, like, oh, students, yeah, we love them, just give us as many as you can. But as much as we like to just assign to them, I work on coaching the agencies in terms of what to expect from the students and what can they do, especially given that this is a class in industrial distribution, logistics, supply chain. What can they do to be defined as part of the scope, but still have a meaningful experience both for the student and the community, because we don't want to pigeonhole them to say, hey, our students can only do this. We want it to be related. So I talked to them initially, and we have very rigorous procedures for our students to be contacting the agencies, like how frequently, every meeting, what should the focus be on, and then we follow up with the agency to say, hey, are the students doing okay? Are they meeting their expectations? So there's a lot of interaction that we manage, so the students and the community agents partners can focus on the project and actually solving the problem and developing solution. But all the coordination of the project, we manage that, just stepping a little bit outside, so they have the space in where they can just collaborate and focus on the problem at hand.
That's absolutely fabulous. Dr. Thompson, so you showed us some work that you're doing at San Jose State, or that you did at San Jose State. Can you give us a taste of any projects that you're doing now at USF?
I'd love to. So one of the classes I'm designing right now that I'm going to be teaching next semester is called Liberatory Design Processes. And so I'm going to get a group of students who aren't as engineers necessarily, are their first years that are taking it for an elective, plus other science students who are just kind of, and anyone on campus who just wants to learn about engineering design processes and design processes in general. And we're going to partner with a 5th grade after school program and co-design what their community might want to look like together. And so we'll do a lot more kind of first few steps in the design process about brainstorming, creating conceptual ideas, and we'll end with having a presentation and inviting the president of this after school program together. And so that's one of the projects. We actually are starting a brand new engineering program at the University of San Francisco. So right now, everything is brand new and we only have freshmen and sophomore. So I'll get to go back to that senior project in 4 years once the students get to that level.
But that must be very exciting to be able to build a new program from scratch. That is exciting. Mary Beth, we have a question about actually a couple of playground questions. One is, do you have any idea why there's a barbed wire fence around that school? But more importantly, there's a lot of there are a lot of design process that are involved in materials, choice of materials that are involved between both blown plastic, metal, wood products. Can you talk about what the benefits are for any one of them, especially in terms of engaging stakeholders in the construction? Can you talk about that a little bit?
Sure. In short, I don't know why the barbed wire fence was there, but I do know that barbed wire speaks volumes.
Yeah.
Whether you're trying to keep people in or keep people out. I mean, I just think it speaks a lot. Yeah, so I wasn't real excited about the barbed wire. I think it's still there, but again, if you do happen to look around a built environment and see barbed wire, I'd be asking, why is it there? And is there something you can do to, sort of get rid of that in terms of, you want to try to build bridges, not build walls. As far as materials and designing, I think every community is different. Every collaboration is different. So I think I saw that the question go through where the question was, do you use prefabricated components? And we mostly use prefabricated components for reliability purposes, but we put them together in unique ways, in custom ways. So it's not a matter of looking at some playground manufacturing catalog and turning to page 36 and saying, hey, that looks like a nice playground, we want that. No, you're really going with what your children have identified for you as the most important things, and you're putting them together in a unique way, and then you're ordering the components specifically. In terms of what kind of materials you're going to use, again, that's usually a conversation that you would have with, with your community partner in terms of what are they looking for. So we tend to use metal just because it is durable and it will hold up to 600 kids a day, 182 days a year for 25 years, where wood may not do that as much. But if you don't have as much, if you don't have that kind of use on a playground, wood can be a very sustainable product. It's really great in natural playgrounds. We definitely have used it and will continue to use it. It's just really a matter of what is your playground and what are your goals? And most of those are defined by our community.
Dr. Christie, I was really struck by the engagement that your students had, especially in terms of environmental justice and working at a Superfund site. And Superfund Sites, again, Louisiana is, it's not one of our better claims to fame, but we have our fair share of Superfund Sites. And I'm curious as to your thoughts about how the work that you did with your students, how that could be transferred to other sites where there's serious concerns of environmental hazards, whether or not they're Superfund driven or not, or supported or not. But we have not a day goes by that you don't hear about a situation of an environmentally dangerous area that's located near a minority community or an underserved community. How transferable do you think your work is to those other areas?
I think it's very transferable. Again, I'm not asking my students to replace consulting engineers.
Right.
But I am asking them to take a deep look at and think about and generate some ideas. So unlike the playground projects where they could actually design a remediation system, build it, and then see the results, my students will never be building these, but they can look at what could be, and then they can compare it with what actually gets done. And your comment about environmental justice is very real and becomes very transparent to my students, most of whom, frankly, well, not most, but many of whom walk into the class somewhat oblivious to the fact that most of these, most of the worst waste sites do tend to get situated in impoverished areas, regardless of the part of the country that we're talking about. And understanding the decisions they make as engineers can help alleviate or continue that kind of injustice. Now, I did make some mention because we had a question in the chat, so I went ahead and answered it. The particular landfill that I showed you the pictures of, that one was the oddity. And in fact, it may be one of the very few ones that I've worked at that actually this site is in the middle of a very nice middle class, if not slightly upper middle class neighborhood, which makes it weird. My students don't realize how weird it is, but also makes it a whole lot safer. Some of the sites that I worked on when I worked professionally, I would not take a group of students to, but this one I can. Moreover, they have local trustees, local government folks who are willing to work with the university and have some resources to move things forward. So it's been a nice relationship for a number of years. We're not doing it now, but it is somewhat of an oddity.
Well, this has been An absolutely fabulous conversation. Just the work that you're doing is really incredible, and certainly is there to help our communities become stronger and better and provide a better quality of life for everyone. And I can't think of a better kind of activity to be doing. Thank you so much for everything that you do, and we really appreciate your work. Thank you all for joining us for an engaging presentation and discussion. Tonight's lucky winner of WRKF's drawing is Kennedy Simon. WRKF will mail you the Science Friday beverage tumbler. We look forward to seeing you again next month on Tuesday, August 31st for a Science Cafe talk with my colleagues in the LSU Digital Media Program, Derek Ostrenko and Hayon Nam, who will present their innovative work where art meets technology. Thank you all so much for attending. We appreciate you joining us. Good night and see you next month.